Yes, in this video, we are going to see what is the geometrical meaning of a gradient and a partial derivative. Okay, so well, let us have a clarity on this. Okay,
Suppose
are you able to listen, right?
Yes, sir.
Okay, let's start.
we have a function of two variables. We have the variable x. We have the variable y. And we have z, which is a function of both x and y. Suppose that we pick one value for x, and we keep x at this one value as we change the value for y. Each time we change y by a small amount, z also changes by a small amount. At each point, the change in z divided by the change in y is given by the slope of this line. Red indicates a negative slope. Let's now pick a different value for x and keep x at this new value. Again, at each point, the change in z divided by the change in y is given by the slope of this line. The change in z divided by the change in y is what we refer to as the partial derivative of z with respect to y. Every point on the graph has a value for the partial derivative of z with respect to y. Here, green indicates a positive value, and red indicates a negative value. Every point on the graph also has a value for the partial derivative of z with respect to x. In this case, the value for y is held constant, while the value for x changes. Suppose we represent the slope of this line with an arrow. The length and direction of the arrow indicates if the slope is positive or negative, and by how much. Every point has an arrow that represents the partial derivative of z with respect to x. Every point also has an arrow that represents the partial derivative of z with respect to y. If we add these two arrows together as vectors, then we'll get a new arrow. Let's call this new arrow the gradient of the function z. This arrow always indicates the direction in which z is increasing by the largest amount. The length of this arrow indicates by how much z is increasing in this direction. Much more information is available in the other videos on this channel. Please subscribe for notifications when new videos are.
Suppose this is your shape. Okay, so your direction, sorry, gradient will give the direction of the function which is maximum value. Okay, suppose let me see. Okay, suppose what is the highest value of this function if you represent any function like f of x. So at which point this function value will be maximum for this shape? Can anyone tell? Where does this function of this shape has maximum value? Yes? Maximum value for this shape will be where? At the top, right? Here. Correct.
Yes, sir.
So, the gradient of any function, like this is, suppose if you take this as a shape of that curve. Okay. So, what does the gradient will give means if you apply the gradient to this surface, okay, what does it tell means it gives the direction where the function reaches highest value. Okay, so that means it will give the direction where you can reach the maximum value in the surface. Okay, so that is called the gradient. Clear? So the gradient is nothing but a direction in which the function reaches the highest value. Clear? So this is about the gradient. Now we are going to discuss about directional derivative. Okay. So as you know, if you are applying dou by dou x of some z variable. Okay. So what do you mean by this means? The slope of any curve in x direction. Okay. Similarly, dou z by dou y gives the slope of any curve in y direction. Okay. Suppose if you are having slope of z overall the surface means this is the gradient, right? By adding these two. So dou z by dou x I plus dou z by dou y j. Okay, this will give the gradient. Correct. Now suppose for this curve I want to find directional derivative means 1 minute. Suppose I want to calculate the slope of this curve in this direction. Okay. So gradient won't give a slope of any curve in particular direction. It will give the overall direction where the function value reaches the maximum. Correct. But directional derivative will give the slope at whatever the direction you want. Okay. suppose at this point, I want to find the slope of this surface. Okay, so directional derivative will give, okay, the slope of this direction. Similarly, if I want to calculate the direction of, the slope of this surface at this point in this direction. Okay, so at this point I need to find. So directional derivative will give the slope of this curve at this point. So how much slope it has been rotated, like that. Suppose if I want to find the slope of this curve at this place and at this point. Okay, so your directional derivative will be like this. 1 minute. At this point I need to find. Okay, so directional derivative will be like this. Okay, at this point how much angle it is been rotated. So like this, using directional derivative you can find the slope of any curve at any place. Clear? And the gradient will give the maximum, it will give the direction through towards the maximum length, like this, like this, like this. Wherever, at whatever the point you want, at that point it will give from there how to reach the peak point of that curve. Okay, that is called the gradient. Clear? So let us do some problems based on this. Clear? So let us see the definition of scalar and a vector field. Okay, if you take every point or any point in a space, okay, so we represent the space as x comma y comma z of a region R in a space. There corresponds a scalar function. Okay, so here phi is nothing but a scalar function, like here phi is equal to x, y, z, or you can write it as phi as x square plus y square plus z square, like without any direction or unit vector. Okay, so if your function has no direction, so then it is called a scalar point function, right? So that is what he has represented. If you don't have any direction for a function, then it is called scalar point function. Okay, then we say that the scalar field phi defined in R. Okay, so where R is nothing but here real space. Okay, next we'll discuss about vector point function. Okay, if every point x comma y comma z of a region R in a space, there corresponds a vector function. Okay, so here a of x comma y comma z represents like this. Suppose vector a is defined as x square y I plus 2xyzj plus x cube zk. Okay, such kind of functions with having unit vectors as a terms. Okay, so this type of functions are called vector point functions. Okay, so then we say that it is a vector field A which is defined in R. Okay, where R is a real space. Okay, so and this kind of functions are called vector point functions. Okay, so as we have seen here, this is an example for scalar point function where we don't have any direction for this. Similarly, phi is equal to x y square z cube. This kind of false functions are also called as scalar point functions. Similarly, functions with directions is called vector point functions, like unit vectors I, j, k. Okay, so this is also an example for vector point function. Vector A is equal to x, y, z, I plus y, z, j. Next, z, k. Okay, so this kind of functions are called vector fields or vector point functions. Okay, so let us see the operators which we are going to use for evaluating that curl or vector point functions or scalar point functions. Okay, so here we have an operator called a del operator. Okay, using this del operator, we'll evaluate either vector point functions or scalar point functions. Okay, so here del is defined as dou by dou xi plus dou by dou yj plus dou by dou zk. Okay, and this whole sum can also be represented as like this. Okay, summation dou by dou x of I. Okay, the meaning of this is nothing but this whole sum. Okay, so similarly we have one more operator called Laplacian operator, del square. Okay, so del square is nothing but dou square by dou x square plus dou square by dou y square plus dou square by dou z square, or this can also be written as summation of dou square by dou x square. Okay, so if you observe these two operators, del and del square, del is a vector quantity. Okay, and this is a scalar quantity. Is it fine? So del square is represented as scalar quantity and del is represented as vector quantity. Clear? So let us see how we'll apply these operators for whether a vector point function or scalar point function. So first we'll discuss about the gradient of a scalar field. Okay. So if phi of x comma y comma z, which is a scalar point function which is continuously differentiable. Okay, so that means you should be able to differentiate that function. Okay, then the gradient of phi is defined as del phi. That means you are applying operator for a scalar point function. Okay, and the gradient phi is defined as del phi is equal to, you are applying that phi to each and every term in that operator. Okay, and finally the result as gradient of some scalar point function which gives the vector quantity. Okay, so let us see one example based on this. Suppose my point vector scalar point function phi, I am defining it as a x square yz. Okay, so implies gradient of phi is defined as del phi, which is nothing but dou phi by dou x I plus dou phi by dou y j plus dou phi by dou z k. Okay, so you need to apply this phi for each and every term in that operator. Okay, so if you apply it, how much you'll get? Dou by dou x of here what function you have taken, x square yz, right? Yz I plus dou by dou y of x square yz j plus dou by dou z of x square yz k. So So differentiate these functions partially with respect to x. So how much you'll get? First differentiate with respect to x. So I think you'll get 2x yz I plus here differentiate the same function with respect to y. So differentiation of y is 1. Remaining things you have to keep it as constants. So I'll get x square z j plus differentiation of this with respect to z. So differentiation of z is 1. So I'll get x square y k. So this is the value of del phi. Yeah. So like this we are going to apply del operator for a scalar point function. Okay. So let us see some more examples on gradient of a scalar field. Okay. So I have taken gradient of the scalar function phi is equal to x square plus y square plus z square. Okay, so let us see. Gradient of phi is equal to, how to represent it? It is denoted by grad phi, and this can also be denoted as del phi. Okay, so let us find what is del phi. So del phi is nothing but dou phi by dou x I plus dou phi by dou y j plus dou phi by dou z k. Okay. So this one is equal to, so apply this phi value in each and every term. So where phi is equal to x square plus y square plus z square, right? So dou by dou x of x square plus y square plus z square I plus dou by dou y of x square plus y square plus z square j plus dou by dou z of x square plus y square plus z square k. So this one is equal to, differentiate this function with respect to x. Yes, Dhanya, can you say the answer? Differentiation of x square plus y square plus z square.
2x 2xi plus 2yj plus 2zk.
2xi plus 2yj
yj plus 2zk.
2zk.
Okay.
So that's it. Okay. So this is the value of gradient phi, or you can write it as grad phi. Fine. So just try one more example. Phi is equal to x square y cube z square. So everyone try this problem. Gradient of phi. So it is denoted by grad phi. In terms of operator, we'll denote it as del phi. So del phi is defined as dou phi by dou xi plus dou phi by dou yj plus dou phi by dou zk. So that means dou by dou x of here x square y cube z square I plus dou by dou y of x square y cube z square j plus dou by dou z of x square y cube z square k. So try to find the partial derivative for this.
2x y cube z square I
is 2x y cube
Z square I
z square I
plus
plus
3x square
3x square
y square
y square z
Z
square
square I J
j plus
plus 2x square y cube
2x square y cube
ZK.
zk. Yes, is it fine? Everyone got understood? Is everyone understood?
Yes, sir.
Yes, sir.
Any doubts are there here?
No, sir.
Try to find the answer for this. Miss Ashwita, can you tell the answer? What is the value of gradient phi or del phi? Ashwita, are you there?
Yes, sir.
Can you tell the answer?
3x square plus y cube plus z cube minus 3yz.
No. First, differentiate this function with respect to x. How much you'll get? First term is correct, 3x square. Differentiation of x with respect to y. Sorry, differentiation of y cube with respect to x. So I'll get 0 here, right? Second term, third term also 0. So in last term, how much you'll get?
3yz.
Minus 3yz I. Correct. Yes, Ashwita, have you understood?
Yes, sir.
Next, can you tell the next term?
Three y square minus 3xz.
3xz. J. Next third term.
3z square minus 3xy.
3xy. So into k. So like this, you'll get the answer. Fine. Everyone got the same answer? Do it step by step, okay? So this will be the answer. Is it fine? We'll go for next topic.
Yes, sir.
Yes. Okay. Next we are having one more operator, the same thing. Del operator, we are making a dot product with vector function. Okay. So let us see the definition of divergence of a vector field. Okay. So if a of x comma y comma z is a vector point function which is continuously differentiable. That means this should be differentiable vector function. Okay. So then the divergence of A is denoted by div A and is defined as dot product of del over A. So that means del dot A. Okay. Suppose if you understand the definition clearly, so here I am taking A is equal to A1i plus A2j plus A3k is my vector quantity, where A1, A2, A3 are the functions of x, y, z. Okay, so A1, A2, 3, A3 are the functions of x, y, z. Okay, so then we'll apply divergence as div A is equal to del dot A. So dot product of dou by dou xi plus dou by dou yj plus dou by dou zk dot A1i plus A2j plus A3k. So if you apply the dot product, what happens? So as we have learned in previous, first topic we have discussed about dot product, right? So you have to apply I terms to I term, j terms to j term, k terms to k term. So apply these operators for I to I term, j to j term, and k to k term. So that means dou by dou x of A1 you have to apply first. Next dou by dou y of A2 you have to apply next. Next dou by dou z of A3 you have to apply. Okay. So where I dot I, j dot j, and k dot k are 1, right? Because we are having the property like I dot I is equal to j dot j is equal to k dot k. So dot product between the same unit vectors gives the result as 1. So the resultant of divergence is a scalar quantity. Okay. So the resultant value of a divergence is a scalar quantity. Okay, fine. So we'll discuss about some problems based on it. So here, this is my function which I have taken here. So let us see how to find the divergence of this function. Okay, so solution, divergence of mu is equal to, how to apply? It can be denoted by div A or div mu. Here the vector quantity is mu, right? So this is nothing but del dot mu. Okay, so let us find what is del dot mu is equal to dou by dou xi plus dou by dou yj plus dou by dou zk. So this is nothing but your del operator. You are making dot product of given function. So mu is nothing but xz cube I minus 2x square yz j plus 2yz power 4 k. So this one is equal to, so you have to multiply I terms to I term, j terms to j term, and k terms to k term. Okay. So I dot I, j dot j, and k dot k value will be 1. So apply first operator to I term. So that means dou by dou x of xz cube, where I dot I is 1, so no need to write anything, plus dou by dou y of second term. So minus 2x square yz plus dou by dou z of 2yz power 4. That means third term. So this one is equal to, Ishran, can you tell the answer? Ishran? Darshan? Can you tell the answer? Dou by dou x of x
Y
z cube.
Z cube
Z cube
minus
plus, okay, minus minus
2x square Z
2x squared z
plus
plus
4
4
Z cube
4z cube
into 2y
into 2y. So total how much? 8
8
y z
y
cube, na?
Z cube.
Okay. So this is the value of del dot mu. Fine. So in this way you have to apply. So remember gradient of some function phi is nothing but del phi. Okay, you should not apply anything between in it. Okay. So whenever you see divergence of phi, so this is nothing but you have to apply dot product between these two. Fine. Don't get confused between gradient and divergence. Is it clear? Is there any doubts here in evaluating
No, sir.
divergence?
No,
Yes? No, right?
no, sir.
Okay. Yes. Similarly, shall we try this? So find the divergence of mu is equal to this function. Okay. So first write what is divergence. Divergence of mu. This is nothing but it can be denoted by div mu. This is nothing but del dot mu. Okay. So let us see what is del dot mu. So where mu is a vector quantity, so you have to write arrow mark for this. So del dot mu is equal to dou by dou x I plus dou by dou y j plus dou by dou z k dot. So 2x y square z cube I minus y cube zj plus 7x cube y z square k. So this one is equal to how to apply dot product. How to apply this operator to only I term. Next j term to j term. Next k term to k term. Okay. Yes, Drishya, can you tell how to apply the operators?
Yes, sir.
Yes.
Two y square, 3x square.
No. First tell how to apply. That's later we'll differentiate.
Okay. Dou by dou x, 2x y square x cube,
Y square x z cube.
z cube
Uh,
plus dou by dou y minus y cube z
okay.
plus dou by dou z 7x cube y z square.
7x cube y z square. Correct. Yes, can you tell the answer now?
Yes, sir. 2 into y square z cube
Okay.
um, uh,
minus
minus 3y squared z
okay,
plus 7x cube y 2z.
so how much you'll get? 2 into 7. You'll get
14
4.
x cube z.
Okay, x cube yz. Correct. So y will be there. So z you are z square you are differentiating, you'll get 2z.
Yes,
Correct.
sir.
So the answer will be del dot mu is equal to this much. Is it fine? Any doubts? Anyone? Need one more example or we'll go for curl? My voice is getting echo.
Now it's fine, sir.
Okay. Yes, shall we move for curl or we need one more example?
So one more example.
One more example, okay. Suppose find the divergence of mu is equal to, I'm taking the function as x square y cube I minus 2 sine x z j plus log of x y z k. Okay, so let us see how to find the divergence of this. So let us see the solution. So divergence of mu is equal to del dot mu, right? So here del dot mu we need to find. So let us write in detail. Dou by dou x I plus dou by dou yj plus dou by dou z k dot x square y cube I minus 2 sin x z j plus log x y z k. So this one is equal to dou by dou x of. So first we have to apply I term to I term, correct? So x square y cube I plus dou by dou y of minus 2 sine xz j. So keep a bracket for this plus dou by dou z of log x y z k. So this one is equal to, can anyone tell the answer?
2x y cube
2x y cube
minus 0
minus, so why? Because here y
no
term
y
is not,
term
so we'll get 0 j
0 plus 1 by x y z
x y z
into k into
into
x y
x y.
y.
So I'll get k.
No k, sir.
K,
Ah,
no
yeah,
k
yeah.
won't come, right? K won't come. Here also ijk won't come. Correct. You're simply seeing here
Yes.
the resultant of this is a scalar function. So this one is equal to how much? 2x
2x y cube
cube,
plus 1 by y 1 by z
plus 1 by z.
z.
Is it fine? Any doubts here?
No, sir.
Satvirai, any doubt here? Satvirai, are you there?
She's there, sir. She has some issue with the microphone.
Okay. So is there any doubt?
Sir, how it is 0, sir?
Huh? So
Sir,
here
made it up.
differentiation of 2 sine xz is there. If y is there, you can differentiate, right? You are treating except
Okay.
y, all other variables as constants. So here y term is not there. So this term will be 0, right? Differentiation of a constant, it is 0.
Yes.
That's it. Suppose if you are having dou by dou y of sine xy. So then what you will get? Differentiation. Here y term is there. So at the time you will get cos xy into differentiation of xy is x. So the overall answer is x cos xy.
Yes, got it.
So but here xy is not there, xz is there. So we have to treat that constant, these terms as constant. Differentiation of any constant is 0. Correct. So like this, you have to understand. Differentiation of other variables with respect to y. So then it is a constant. So you have to put 0. Differentiation of the constant value is 0. Is still any doubts? Next we'll go for curl. So like the same thing as we have discussed in the previous topic. So A is a vector point function. Okay, which is continuously differentiable and
Sir,
curl of
sir.
A. Yes, yes.
Satyam can't join the meeting, it seems.
What happened?
I don't know.
Sir, I am there in the
When
meeting.
Satyam and Harsh.
Harsh,
Then
Harsh.
who left? Harsh.
Harsh
Sorry,
is-
not Satyam. Harsh. Not Satyam.
Okay, try using the same link.
I'll give.
Tell him to try using the same link which I have sent in WhatsApp. Even if it is personal mail ID also, I can allow. Okay, otherwise you tell him to go for Google Classroom, and from there you can put that video icon will be there now. From there he can join. From Google Classroom, just tell him to try if he is registered in it. Is it fine? Shall we continue?
Yeah, I said him, sir. Yes.
Okay. So you tell him to join through Google Classroom, where if you enter the Google Classroom, one video icon will be there. If he click that, directly he can join this class. Okay. So we'll continue. If A is a vector point function which is continuously differentiable, okay. So then it is defined as, the curl is defined as del cross A. That means we are applying cross product with a vector function. Okay. So curl A is equal to del cross A. As you know, whenever you are applying cross product between any two vector functions, it can be defined as determinant of I, j, k, dou by dou x, dou by dou y, dou by dou z, a1, a2, a3. Okay, so that means you are writing the quotients of I, j, k in the first vector and the second vector. And it is defined like this, right? Curl of A is equal to I into, I will be keeping aside. So I will be doing cross product like this. Okay. Similarly, minus j into, like you do determinant. The same way you have to apply the operator. Correct. So I into dou by dou y of a3. Next dou minus dou by dou z of a2, like this. Okay. Similarly, you have to keep this separate. Okay, now you have to apply the operator between I and k. So that means dou by dou x of a3. Next, minus dou by dou z of a1. Similarly, keep this separate. Next, apply operator like this. First, dou a2 by dou x. Next, dou a1 by dou y. Yeah. So like this you have to apply. That means finding determinant only. So we'll see how to calculate. Okay. So and one more also you have to note that the curl of any vector, okay, is a vector quantity. So remember it. So any curl, if you are applying for any vector, you will get a vector quantity. Okay, where divergence will give scalar quantity. The output of that product will give scalar quantity, and the curl of A will give vector quantity. Okay. So let us see one problem based on it. Solution. So here curl mu is nothing but it is defined as del cross mu. Okay, so implies del cross mu is defined as determinant of I, j, k, here x, z, q, sorry, first dou by dou x, dou by dou y, dou by dou z. Next here down x z cube minus 2 x square y z. Next plus 2 y z power 4. So apply determinant for this. So this one is equal to, first take I. So you have to accept I column and I row here. You have to apply determinant for this 2 by 2 matrix. So that means first vector will be dou by of 2y z power 4. Next minus dou by dou z of minus 2x square yz. So I into you have applied for determinant of this matrix. Okay. Next we'll go for minus j into next j. Apply j for that. So how much? D dou by dou x of this one. So that means dou by dou x of 2y z power 4 minus dou by dou y of, sorry, dou z only. Dou by dou z of x z cube. Next plus k into dou by dou x of minus 2x square yz minus dou by dou y of x z cube. So this differentiation you have to do. Okay. So this one is equal to I into, so differentiate this, how much you'll get with respect to y, first term?
2z to the power 4
z power 4 minus, so minus of
plus
minus you get plus
2x square y
2x square
y
y, okay.
minus j into
Hmm.
0 minus
0 minus
3x z square
3x z square
plus
plus
k
k
into
into
minus 4x yz
yz minus
0.
0 will get. Correct. So this one is equal to I into, so differentiate this, how much you'll get? Oh, sorry, you just simplify it. So nothing can be simplified here as it is, 2z power 4 plus 2x square y. Next minus of minus will get plus 3x z square j plus, sorry, minus only. Minus 4x yz k. So del cross here mu he has given. So where mu is a vector quantity, you keep an arrow mark here. Okay. So I need to find the curl of mu is equal to this one. Okay. So let us see how to solve it. Solution, that means curl mu is equal to del cross mu. Okay, so let us see what is del cross mu is equal to I j k dou by dou x dou by dou y dou by dou z. Next you have to write these terms. Okay, so that means 5x square z, next minus x square yz, next x square y square z square. Find the determinant for this. So this one is equal to I into, so first you have to apply like this. Okay, like determinant, how you will apply in the same way. That means dou y of x square, y square, z square minus dou z of minus x square, yz. Next, minus j into dou x of x square, y square, z square minus dou z of 5x square z plus k into, next here like this. So dou x of minus x square yz minus dou y of 5x square z. So this one is equal to, yes, Dhanya, are you there?
Yes, sir.
Yes, can you tell the answer for first term? I into?
Two y
2.
y
That means x square y z square
plus
plus
x square y
x square
y
y. Next, minus j into
2x y square z square
2x
y square z square
y square z square
minus
minus
5x square
5x square. Next, plus k
minus 2x yz
minus 2x
yz
yz
minus 0 minus 0
0. So this one equal to, let us simplify it. So that means here 2x square y z square plus x square y into I. Next, minus j into 2x y square z square minus 5x square minus 2x yz k. So this will be the final answer. So any doubt here in evaluating curl of a vector function? Is there any doubt here?
No, sir.
Okay. So I'll give one more homework problem for you. Just try it. We'll solve it in the next class. If it is understood properly, then we can go for next concept called directional derivative. Okay. So with this, I'm going to conclude the session.